So this. What I'm going to talk about today is Cassiopea xamachana husbandry basics. So I'm Victoria from Penn State University in Monica Medina's lab. And I'm just going to go over some basics for people who may be starting their lab or want some info on how to keep Cassiopea alive. Here we go. So for the Cassiopea life cycle, I'm going to be talking about planula, polyps, ephira, and medusae. Ephira and medusae tend to be very similar in terms of care requirements, so I'm going to lump those together. But let's start with planula. So let's start with general parameters. So in general, I like to keep salinity between 30 to 35. They can survive at higher salinity levels, but if you're keeping them, especially in a controlled lab environment with air conditioning, if you have them in that range, your jellies will be okay. Temperature, if you want your jellies to be alive but lower metabolism, so they're not going to strobolate as fast, they're not going to consume as many resources, 25 is an okay temperature to keep them at. While if you want a lot of production, 27 or 27.5 is what we'll keep ours at if we want them to strobolate. So that's why the range is listed like that. And then most people can purchase a saltwater test kit very easily in any aquarium store. And in those, you can test ammonia, nitrite, and pH. So you want to keep ammonium, nitrite, and nitrate around 0. And I know a lot of people have debated if Cassiopea need nitrates in the water. I found that they're fine if you keep them a little above 0, they'll survive, but they're also perfectly happy at 0. So if you hear an aquarist say, maybe keep them at high nitrates, I wouldn't recommend it. And then pH, you want it in the basic range. So some other considerations is if you're making salt water for your tanks, you're going to want to use clean water. So don't use tap water. There's a lot of dissolved metals and minerals in there that can make your jellies unhappy. So you're going to want to use distilled water or something like reverse osmosis water with the salt water mix. And then if you're pumping in water from the ocean, just be aware of what's happening in the ocean. You hear people who have been using saltwater tables, and then suddenly there's an anoxic event that passes through and all of the animals die. So keep an eye on the weather. And for dissolved metals, there's not too many that you're going to encounter too much, but a lot of the times if you take old aquarium gear or pipes especially, they might have copper in them. And copper is highly toxic to all jellyfish. And if they get in your tank, then the only way to properly remove it is to empty the entire tank, flush it with vinegar for maybe 2 days straight, and then you can start putting animals in it again. So avoid copper. Now with planula, they're easy to collect from any fertile female. So I'll show some pictures of how you can get them, but I can also give a demo at some point during this weekend of how you can do it in person if you like. We look them under a microscope. And for people on Zoom, if that happens, we'll record it. So the thing is, if you have planula, they need a settlement queue to develop into polyps. So you can use things like degraded mangrove leaves, seagrass, or if you're in a lab environment, Artemia eggs also work pretty well. And if you're setting up a tank and you want a good biofilm of bacteria for your polyps to settle, then I like to cycle the tanks by just putting Artemia eggs in them for maybe a few weeks. And then the biofilms that grow, polyps will settle on it. So these two pictures, female and male, with some gonads in the top. But if you zoom in to the center brooding appendages circle of a female, then you can see clusters of eggs that will come out from those brooding tentacles. And planula, when they are fertilized and ready to be released, they will just crawl out of these tentacles at set times during the day. But if you're trying to collect them, you'll probably see a lot of lumps like this. And then if you look at it, this is what they look like. So they tend to be bound in the mucus. You can see all the casiosomes. And then when they are ready to swim away, you will have cilia covered planula that will settle and develop. So when they develop, they're going to be much smaller than your fully established polyps. You can see that the calyx is smaller and the mouth is smaller. So you're going to want to use not something other than Artemia to feed them. Rotifers work well. I know people have used spirulina before. And if you do need to use Artemia, some people have mashed it into a pulp and that has worked. I've never had success with it, but if it works, please let me know. So once you have your polyps, they can be kept in something as small as culture plates. So this is one well of a 6-well culture plate. This is what we use for all of our polyps. but a lot of aquariums like to have hanging plates. So because Cassiopea polyps settle on the underside of mangrove leaves, a lot of aquarists will hang something either upside down or at an angle to have the polyps settle onto it. If you have the space, that does tend to work very well. And you can keep them in as big of a space as you want. So we have 10-gallon aquariums that are full of polyps. They just settle on the walls and the floor. And it's a good way of increasing your upkeep. And as long as they're fed and all of your parameters are fine, they will continuously bud, even if they're aposymbiotic. So for aposymbiotic polyps and symbiotic polyps, very similar care requirements. Of course, if they're symbiotic, you do need light for the algae to function and be okay. I found that the polyps do better with a slightly lower light level than the adults. So if you have them all in a tank together, the polyps are probably going to be found deeper, maybe off to the side away from the light. But if you keep it in an incubator, you can do 70 to 150 micromole per meter squared per second. And this unit is different than Lux. So if you're trying to use Lux, you're going to need to convert the unit. But for aposymbiotic polyps, a lot of people have debated whether or not they need light in order to function. I say they do. If you're wondering about it, wait for Caitlin's talk. So I'm going to show some pictures of healthy and unhealthy of all stages. So on the left, you have a healthy jelly. Very long tentacles, it's budding. That's always a good sign of a healthy jellyfish. But for polyps, you tend to have reduced tentacles, shrinking of the whole animal, and sometimes the entire head will fall off. So like here's a zoom in of one where its tentacles have completely regressed. Here's one where the head has fallen off, and sometimes the stalk will regrow a new head. But if your tank parameters are still off, it probably won't. And then two more examples where they have shrunk and the head is starting to retract. So all of these animals didn't survive after I took these pictures. Now for Aphyra and Medusa, they can be kept together, but you just want to make sure you have enough space. So you want a slow water flow. They do have different care requirements to all other jellyfish and to coral. Coral tends to need a slightly faster water flow. For them, in the wild, it's about the level of millimeters per second for the water flow. And here you see one that has just detached from a polyp, one that's developed a little more, so starting to develop some appendages, and then a full fluffy adult. So some things to account for is that there's going to be constant algae growth in your tank. They expel algae, it's inevitable, but if you have a sump system, so a sump system is where water will flow into your tank kind of from an elevated surface, maybe from an outside source. It helps because if you have a healthy bacteria community and a sump, there will be a lot more churning of the water, and the increased oxygen will help break down the nitrates and nitrites that can really cause algae growth to increase. Then they will need light, so you can either use a full spectrum light or coral lights. And of course, there's the potential for spawning or polyp appearances. So if you're trying to limit how many animals you have in a tank, you want to keep that in mind, because the more animals you have, the more oxygen you need to keep them all happy. So a bare minimal setup. I think I set this up for $50. 10-gallon tank, some lights, a heater, and a pump. But if you want them to be even happier, you want much higher light level than this. So this tank did not have great light, but we still had a lot of Aphyra and jellies everywhere. So they did produce and reproduce. We had a filter with a waterfall on it because that helps the oxygen production a lot in the tank. And then you want some kind of separator from both the heater and any kind of pump or filter from your jellies, because they will get sucked up and get shredded, or for the heater, they have gotten burned from it before. So that's why if you have the choice, having something a bit more advanced is much better. So for instance, here, all the jellies are in one plastic container with an outflow and inflow pipe. So there's no chance of them getting sucked in. This was all in a room that was temperature controlled, so you don't have to worry about your heater failing or burning your animals. And then this is an example of a sump. Sorry, I almost said pump. So if you have the space, you can have a sump setup underneath your table. I didn't have a picture of this. I thought I did, but I've set up a sump within a single tank before. So if you'd like to see that picture, let me know. And the light levels for Aphyra and Medusa, you're going to want it more in the range of 200 micromole per meter squared per second because of data that Marta has. We know that if you have it around that level, then they're undergoing more autotrophy than heterotrophy. So, bad signs of unhealthy Ephira medusa. I found if you keep them in a tank, the oral arms will shrink first, and then the bell will shrink second. Sometimes they flip inside out. I've seen it happen. Sometimes they flip back. Sometimes they die. So if you see it, don't panic yet. Just try and kind of right them again. If you see discoloration, so that's another potentially bad sign. So if they're getting very pale or white, it might be that your light is too high or a reflection in your tank is too high. So even if your light itself might be not the highest intensity, you're going to want to measure to see if, for instance, it's sitting on a white table, all that light's going to be bouncing back onto your jelly. So keep that in mind. But if they're getting a very dark brown, then that's typically when the light is too low. So they will still be fine, but when we had low light levels, it meant we had to feed our jellies like every single day, sometimes twice a day, to get them to stop shrinking. Of course, if the pulsing stops, that's a bad sign. I've normally found that to be an issue with temperature. And then if you have mucus production happening other than after you've fed them Artemia. So here on the left, we have healthy Ephira, oral arms, bell margins intact. It just ate an Artemia, that's what that is. Well, here are some examples of unhealthy. So here you can see the oral arms have shrunk to almost nothing, even though the bell is intact, and vice versa. The bell has shrunk to almost nothing, and there's a cluster of mucus on the side of it. So if you see mucus attached to your jelly and it looks like the tissue's degrading, it's probably degrading. Here's a dark animal, so the light was not high enough. And then I just threw an example of one that flips inside out. That one was fine afterwards, but if you see that, don't worry about it. So again, unhealthy one, you can see a lot of mucus coming off of the bell of this one, as well as obviously, most of it degraded. And then a zoom in of one. So this is actually mucus peeling off of it, not the epithelium, but all of its oral arms just fell off. So, because I'm running low on time, just some challenges and strategies you want to think of. Have backups of everything. It doesn't matter if you think, oh, I have warranty on this item, have a backup, because if it breaks at midnight and you have to rush in, you want a replacement. Getting the right light level is pretty crucial, because if you have that correct, you can also limit how often you have to feed them, which can be really great if you don't have a whole lot of people helping you or you have a tight schedule. And it's a full-time job. So try and have a team going and maybe multiple people to monitor said team to help keep track of everything. So I'll take questions, and then if you have more questions that you just want to email me, that's my email. Julia?
I know that for the Cassiopea is basically a stage at the moment when they pass from a single component to a stage when we do the harvest in the cross harvesting. In this stage, do you know if feeding them Artemia because polyps, with polyps, they can actually even digest Artemia. But I think in that stage, when they go from that following the other ones, we know if they are actually able to where the gas is small, they just a bit later than if I write small kind of global.
Okay, so the question was if I know that when an Ephira is going from when it first attaches and the mouth is relatively small or underdeveloped to when it has all of its oral arms developed, if there's a difference in size and quantity of what I feed them. Sorry. Okay. So what I found is right when they detach from a polyp, they don't eat anything until the oral arms, because they start off with 4 sets and then they bifurcate into 2 more. When that happens, they'll start eating again. So it doesn't really matter what you try to give them, because they'll get a little bigger then anyway, and then I feed them Artemia and they're fine.
When you want to get aposymbiotic polyps from a planula, when you want them to settle and grow into aposymbiotic polyps, how do you, like, number one, do you have any general tips? Number two, when you're feeding them like rotifers or something, how do you make sure how can you make sure they stay aposymbiotic?
Okay, so the question was, if you are getting planula, any tips on getting them aposymbiotic? And then if you're feeding them something like rotifers, how do you make sure they stay aposymbiotic? So I'll answer the rotifer one first, because that's a bit faster, but for rotifers, you can feed them this like phytoplankton paste kind of thing. And when they eat that, that's not a dinoflagellate that they can get symbiotic with. So if you stick with something that is purely no dinoflagellates in the culture and feed those, then it'll be fine, because we've been doing that and it's okay. But for the planula to polyps, I'd say, sorry, there's a mosquito on me. I would say that if you take the planula, put them in a filter that is big enough for the dinoflagellates to wash through, but not the planula, rinse them with filtered seawater at least 3 times, and then put them in a plate. If you want, you can put them in the dark too. That'll kind of ensure that any algae that's there won't divide, and then just transfer them as soon as you can check under a microscope that they're aposymbiotic. That should be good. And I didn't mention it, but we have freezer stocks of a bacteria that if you put it in the water, it forms the biofilm that induces settlement. So if anyone wants any, I can ship some to you.
There are some questions on Zoom, I can read them out. Or read them out.
No?
Oh,
Do you want
I can ask, I was gonna ask them, but you can go ahead and ask.
Oh, or you could just read out the question.
Okay. So I'm going to go through the Zoom questions now. Here, I'll put it on this chair. All right, so I think that's Edney. Hi. Where do you measure the light intensity of your Medusa aquarium? At the bottom. So I measure at the top and the bottom. The jellies tend to move around, so you're going to have a distribution of light the closer you are to your light source. So I tend to make a chart, a 3D picture, and measure each corner at the top and each corner at the bottom, and then in the center, just to get a good distribution of the light. And then, did you notice if there were certain tank materials that the jellyfish lived better in? Mine seem to do much better in glass than plastic. Yeah, I've noticed that. They do better in glass for sure than plastic. And I think it might be more that plastic can have uneven surfaces that you can't see with the human naked eye. But if you get under a microscope, they'll have scratches, bumps, all of that. That's it.